Hello everyone, this is P. Ashwant from III-ECE. My register number is 4B6. The topic is directional antenna for K equal to 7 in 3 sector case. The mobile unit at position E will experience greater interference by lower shaded cell sectors than in upper shaded cell sectors. Because the mobile unit receiver receives weak beep signal from its own cell side and string information from other interfering cells. The directional antenna will be effective in reducing the interference in one direction, and the front to back ratio of directional antenna will be 10 decibels or more. In 3 sector case, by the use of directional antennas, the number of interference are decreased from 6 to 2. Then the C by I ratio will become, as the C is proportional to R power minus 4 and I is proportional to D power minus 4, the C by I ratio becomes R power minus 4 by D plus 0.7 into R whole power minus 4 plus D power minus 4. We know that D by R equals to Q. So we divide the equation with R, and Q equals to D by R, that equals to root 3K. So here the K is 7. So 3 into 7 root 21, that is 4.6. And the obtained Q value is substituted in the C by I equation. Then the C by I value becomes 285 or 24.5 decibel. So by using the 120 degrees antenna directional antenna setter system, we the obtained C by A ratio is exceedingly greater than 18 decibels, but in reality it will be 6 decibels weaker in high traffic areas due to irregular terrain configurations or imperfect site locations, but the remaining 18.5 decibel is adequate for good voice quality. Directional antenna system for K equals to 7 in 6 sector case. Due to use of 60 degrees directional antennas, the number of interfering cells are decreased to 1. Then the C by I ratio becomes R power minus 4 by D plus 0.7 R whole power minus 4. So we divide the equation with R on numerator and denominator. We get D by R as whole. So the D by R is Q, we know that. And D by R equals to Q equals to root 3K. So the K is 7 in this case. So root 3 into 7, that equals to 21, that equals to 4.6. So the value D by R equals to Q equals to 4.6. So we will substitute 4.6 in the C by I equation in for 6 sector case. Then the C by I ratio becomes 794 or 29 decibels. So if we reduce the 6 decibels, which is due to in high traffic areas due to irregularity in terrain configurations or some imperfect site locations, but still the remaining 23.5 decibels of C by A ratio is more adequate. So in heavy traffic areas, we prefer 60 degrees directional antennas to reduce the co-channel interference. Thank you.